Here we have a pre-calculus problem. Okay, let's go to the question. Solve for n. np5 equals to 12 times n negative 1 p4. N equals to. Okay, here we have a permutation. There is np5 and n negative 1 p4. In the given equation, we have to find the value of n. Okay, now let's consider permutation in general form. That is npr. So the value we have over here is called n. There is a number of things given, and the value we have over here is called r. There is a number of things we select and arrange them in a particular order. There is a formula to find the value of this permutation. That is n factorial divided by n negative r factorial. As soon as students see this kind of questions, immediately they will start using the formula what I have given over here for this np5 and n negative 1 p4. Actually, when r is given as a numerical value, we don't have to use this formula. There is a shortcut to get the value of the permutation. Okay, here in both the permutations, r is given as a numerical value. When I consider the first permutation over here, r is 5. In the second one, r is 4. In both the cases, r is given as a numerical value. Since r is given as a numerical value, we don't have to use this formula. We can use a shortcut to get the answer quickly. Okay, what's the shortcut? For that, let's consider a permutation that is 7p3. Okay, here the value of n is 7 and the value of r is 3. Since the value of r is 3, the value of n, that is 7, has to be reduced for the next 3 integers and multiply them. Then we get 7 times 6 times 5. So when I multiply these 3 values, that's the result of this permutation 7p3. So here 7 has been reduced to 3 integers for the next 3 integers, consecutive 3 integers, because the value of r is 3. For example, if I have 7p4, what should I do? The same thing, that is 7 has to be reduced for the next 4 consecutive integers because the value of r is 4. Then we get 7 times 6 times 5 times 4. So this is a shortcut to get the value of the permutation when r is given as a numerical value. Okay, now the same logic what I have explained over here in our problem, we can do it. Okay, now let me take the given equation, that is np5 equals to 12 times n negative 1 p4. Okay, here r is 5, so the n has to be reduced for the next 5 consecutive integers and multiply them. Okay, let me write n first. The next consecutive integer has to be, we have to subtract 1 from this n, then we get n negative 1. To get the next integer, we have to subtract 1 from this n negative 1, then I'm getting n negative 2. Then when I subtract 1 from this one, n negative 3. Then when I subtract 1 from this one, I'm getting n negative 4. 1, 2, 3, 4, 5. Okay, now n has been reduced for the next 5 consecutive integers and multiplied all of them, equals to 12 times the same thing. This n negative 1 has to be reduced for the next 4 consecutive integers and multiply them. So n negative 1, the next one, we have to subtract 1 from this n negative 1 to get the next integer. Then we get n negative 2, then we get n negative 3, then we get n negative 4. 1, 2, 3, 4. There are 4 consecutive integers. Okay, now when I consider the stuff on the left side, we get n negative 1, n negative 2, n negative 3, n negative 4. The same stuff we have over here. When I divide both sides of this equation by n negative 1 times n negative 2 times n negative 3 times n negative 4, all the 4 terms over here will be cancelled. The same thing will happen on the right side as well. So now on the left side we have left with n, on the right side we have 12. Now I got the value of n. So therefore the value of n is 12.